Watch this. I ask for an entire scraping pipeline in one sentence. The AI reads my rules, writes its own implementation prompt, and asks me, is this good to execute? I say yes, and it builds the whole thing. That's the video. So let me show you how to set it up. What if your agent didn't just build your feature, but wrote the prompt for it too? Be honest. How many times have you gone back and forth with AI on the same feature and still not gotten what you wanted? You know what you needed, you just didn't know how to say it in a way that AI actually understood. That one thing kills more AI projects than anything else. So, hi, I'm Adrian, and in this video, you'll flip that problem around. You'll make the AI write its own implementation prompts. You'll then just review and approve them, and it builds the entire app from there. And to prove this works on something genuinely hard, you'll build Skew, an AI-powered news platform that pulls in real news and show you just how biased every article is before you even open it. So here's what you'll build. A home feed of real scraped articles with a bias metric right on every card. A news details page with the full article, AI summary, sentiment, framing percentages, related articles matched by meaning instead of keywords using PG vector semantic search, authentication with middleware, protected routes, and redirects, and a fully automated pipeline that, when it scrapes the data using Oxylabs, it then filters, saves, and analyzes fresh news every hour. You'll build it with Next.js for the full stack app, Supabase, the build-in-a-weekend backend that is also super powerful to run production apps using Postgres, PG vector, and the entire data layer, Clerk for complete authentication and user management, so you're not rebuilding what you've built 10 times. Oxylabs, an award-winning web data platform for scraping real news sites that ensures uninterrupted access to public web data. PostHog for analytics and session replays, so you ship products and not just code, and you can get access to it directly through their Slack integration. I'll show you how that works. Vercel AI SDK for structured AI analysis for every article, and of course, Tailwind for styles and TypeScript for safe code. All the in-demand industry tech and every feature, every route, and every component of it will be built by the agent. But the app is not the real takeaway. Skew is just how you learn it. The real takeaway is the workflow, an approach I call vibe engineering, where you define your product, write your AGENTS.md, and then let AI draft its own prompts, approve them, and build in small, focused steps. Master that once, and you can build any app after this. Same system, different idea, same results. And to make it stick, I prepared a free vibe engineering guide that lays out the entire workflow step by step, so you can apply it to your own projects, get that job, get that gig, or just become a better developer working with agents. Link is in the description, so you can go grab it. And if you want the version where the AI does even more of this for you, planning and reviewing its own work, and handling the enterprise stuff, which doesn't fit in this video, that's what I'm building into the Agentic Engineering course. It's not out yet, but the waitlist link is in the description, and the founding price goes to that list first. Check it out, and without any further ado, let's dive right in. Okay, so you know how to code with AI. Small prompts, one task at a time, AGENTS.md holding some project rules. That works really well for most apps. A marketing site, a dashboard, or a SaaS tool with a clear scope. You keep the momentum, and you can always see what just happened before moving forward. But at some point, you hit a project that breaks that flow. Not because the approach was wrong, but because the project is complex enough that a short prompt leaves out too much. A scraper that feeds a processor that feeds an AI step that feeds a UI. If one step is wrong, everything after it is wrong too. So you naturally write a longer prompt to compensate. And now you're spending 20 minutes writing a prompt before you build anything. But the whole point of short prompts was to move fast. You've probably been on the other side of this too, front-loading everything, 9 markdown files, a whole planning system to fill out before the project could even start. Lots of context for AI, but you're doing most of the thinking the AI could have done for you. So the question worth asking is this: if the AI is smart enough to write code from your instructions, is it not also smart enough to write the prompt from your instructions? Because these models have gotten genuinely capable. Point one at a skill file or a piece of documentation and tell it what has to happen. And it doesn't need you to pre-chew every technical decision. It can figure out the steps, identify the files that need to change, and write the implementation prompt itself. What it needs from you is direction, not a script. Direction. So what are we building? What must stay separate? What tools do we use? When to ask before assuming? And how to structure its outputs so that you can verify it. That's the whole model. You stay in control of the decisions, and the AI does the planning work, and then it builds what it planned. That's what I like to call vibe engineering. We always start in that same file that AI works with. But for a complex project, it holds one thing more than just your stack and folder rules. It describes how you want features to be built, not what features to build. The thinking process. When you sit down and build something yourself, you don't start typing. You ask, what does this feature do? What data does it need? Where does that data come from? And what could go wrong? That process is what goes within the AGENTS.md file. Not the answers, but the process. So the AI runs it on every task before touching a file. Concretely, the file covers the workflow steps, what the product is and is not, how the layers relate, which tool owns the job, the data model, the API method contracts, security rule, code quality preferences, and a fallback rule for anything the file doesn't cover. And since this is a lot to remember, in the description down below, I'll leave a free guide that you can always refer to and just get it set up for your own projects. But only 3 of these things do the heaviest lifting. So here's the idea behind them. The out-of-scope list. See, AI agents love adding features that just sound useful. Comments, bookmarks, notifications, dashboard. They're not bad ideas, but they're just not for your plan. So write down what's out and they will stop appearing. The data model with hard rules. Define once what the article needs, such as an image URL or a published date, before it can be saved, and then the AI will enforce it in the scraper, in the validation, and in every feature that touches that article. Written once and enforced everywhere. And finally, the fallback rule. It's just one numbered list at the bottom for situations that the file doesn't cover. Build the smallest thing possible, ask a focused question if unclear, save a prompt, get approval, implement it, and share the test steps. This is what stops the AI from making a large independent decision in a situation that you didn't anticipate. And you'll see a full AGENTS.md file for the news app we're building in this video, line by line when we set it up, every section with all the reasoning behind it. But yeah, once the AGENTS.md has the project rules, we then add skills on top of it. A skill is a dedicated file for one tool. The Clerk skill holds how to implement Clerk properly. Supabase skill holds query patterns and row-level security. The Scraping skill holds how that service works. So AGENTS.md is about your project, and the skills are about the tools. So when a library updates, you update one skill file. When you start a new project with the same stack, you bring the skills and write a fresh AGENTS.md. In your prompts, you just reference what's relevant, like implement Clerk Authentication using the Clerk skill. One sentence, AGENTS.md has the project context, the skill has the tool knowledge, and you wrote neither into the prompt. And these skills are something that you can find for the tools you'll use, or you can build them yourself. For the Agentic Engineering course, I'm building a full custom skill set that goes further. Skills that interrogate you about a feature before planning it, push the grunt work to cheaper models to save tokens, and review the finished code with a different model than the one that wrote it. That's going to ship with the full course. I'll leave the link down in the description if you want to join the waitlist. But the thing that makes Vibe engineering, the process that I'm going to teach you in this video, different is that AI writes the prompt before it writes the code. Before touching any file, the AI will write a prompt, save it as a markdown file in a prompts folder, and ask you whether it's good enough to execute. And it's not a vague summary, it's a specific document. It contains a goal, which is a one clear sentence, what it read, like which skills and existing files, what it assumes, like small decisions that it can resolve on its own, what files will change, containing the exact list, what it'll build based on specific requirements, the security requirements, so what stays server-side, what the route rejects, acceptance criteria, checks to run like type check or lint, and finally, how do you verify it with step-by-step instructions. That last one matters most. For an API feature, it's exact curl commands. For a UI feature, it's what to click. Or for a database migration, it's the SQL code to verify. The AI isn't just telling you that it built the thing. It's telling you how to confirm it yourself, and it wrote that down before building it. And then it asks you just a single question. It says, I prepared the implementation prompt in this folder. Is it good enough to execute? You read it. If it's wrong, you say so. If it's good, you approve. And then it builds. You review the prompt, not the code, and you catch problems before they become features that need to be undone. And when the AI hits a decision that the AGENTS.md doesn't cover, something that could reasonably go two ways, the rule is always ask before assuming. Not mid-build, but before the prompt. That way, the decision gets made by you at the right time instead of by the AI in the wrong place. And that allows your everyday prompts to stay short. All of this setup has one payoff. Implement Clerk Authentication using agent skills. Implement the database schema and data access using Supabase skills. Or implement the homepage from the attached design. 1 or 2 sentences each, the AI reads the context it needs, plans the feature, saves the prompt file, asks for approval, and finally builds it. That way, you're not writing a long prompt for every feature, but rather you're maintaining a file that makes long prompts unnecessary. And then you simply build in order. Not because anything stops you from building out of order, but because the wrong order means building against uncertainty. UI decisions can't happen before you know what the data looks like, and integrations can't happen before the database that they depend on actually exists. So in Skew, our news application, the order is like this: design system, UI, Clerk Auth, Supabase schema, Oxylabs Scraping, AI analysis, PG vector for related articles, and then the scheduler and cron that run it all automatically. One prompt per step, each approved before implementation. That way, you'll see how each one of these steps connects as we go. And if you've been following the channel, you know that there's also a third approach that I've taught you. The first one was front-loading everything. 6 markdown files, long planning documents, full prompts before you write any code. That's lots of context, but most of the planning work was done by you. Then there's practical vibe coding with short prompts, AGENTS.md one task at a time, which is great for most apps, but messy on anything complex enough that a short prompt leaves out. And then this video is about vibe engineering, and it sits somewhere in between. You write the AGENTS.md and a small set of skills, your prompts stay short, and then the AI writes the detailed prompt for you. That way, the AI does more of the planning work, and you control more of the decisions. The right things are written down once and used everywhere. And that covers some more complex projects. But there's a level past this, and it's the one the agentic engineering course is built around. It follows the same core idea. You own the decisions, and the AI does the work. but the skills do far more of the thinking. They interrogate you before they plan. They pull in each framework's own current agent skills, so you're not getting plausible but dated code, and they review the result with a different model than the one that wrote it. Plus, what this video can't fit, onboarding a legacy codebase that you didn't write, recovering a project that has gone sideways, or running agents in parallel without them stepping on each other. You'll feel where the by-hand version runs out of room in this build. The course picks up right there. It's not out yet, but the waitlist is linked in the description. The founding price will go to the devs that are on that list first. And I'd very much like to see you there, because the official JSM skills are something that we've been working on for the past year. And in the course, I'll teach you how to use them to become an agentic engineer. But in this video, Skew is the project. The workflow is what you're learning. Do this once, and you can do it for any web app at any level of complexity. Define how the parts connect, write the AGENTS.md file, add the skills, and then work through it one prompt at a time. The project changes every time, but the way of working stays the same. And you'll direct the AI, but the AI still can't create your accounts or hand you your own API keys. So before we build, let's get 4 of these ready. Each one is free, and each is what makes a specific part of our application work. We'll use Clerk for authentication, and it's more than just a login box. It's a complete user management and billing, allowing you to drop in, sign up components, and a stack of OAuth providers. The free hobby plan covers 50,000 monthly active users, so you can build and launch without paying anything. So, since we use it in this application, click the link down in the description, create your account, and then create a project that you're going to use for this app. We'll also use Supabase for the database. It's what I would call a build-in-a-weekend backend that still scales to millions, with Postgres, instant APIs, row-level security, storage, real-time, and edge functions, all of it on a free tier that's great for building and testing. The app we're going to build today uses it as the source of truth for sources, articles, AI analysis, scrape logs, and scheduler runs, and its PG vector extension is what powers the related article search later on. So once again, click the link down in the description, create your free account, and then a project within it for the app we'll start building right now. We'll also use Oxylabs for scraping. It's an all-in-one web data platform with a web scraper API on a free trial and a free scheduler for recurring jobs. News sites actively block scrapers. Oxylabs manages proxy networks and geocomplexity legally to deliver clean data, and it's been awarded the best proxy service. We're going to use it in our app today to pull real articles off real news homepages and then keep them coming in automatically. It can collect real-time data from almost any public website, scale effortlessly without you having to manage those browsers, servers, and proxies, and integrates with tools that you already know, like Puppeteer, Playwright, or workflows like N8N. And it even has MCPs for Claude and Cursor. On top of that, it offers very low latency scraping, 24/7 support if you need it, and has been recognized as one of the best proxy services. Make sure to go to oxylabs.io/JavaScript to get a free trial with up to 2,000 scraping results free and no credit card required. Plus, you can use my code JavaScript for 20% off all of their plans. I'll leave the link down in the description so you can create an account and follow along nicely. And we're using PostHog for analytics that act on itself. PostHog will capture how people actually use your app, including analytics, session replays, and feature flags. But it's moving past dashboards into what they call self-driving. Agents that read your product data and open pull requests to fix what they find, plus a Slack app that you can tag to ask data questions or ship a change without even leaving the thread. It's free up to 1 million events and 5,000 recordings a month. We're going to use it in our app today so you learn how to ship products, not just the code, and so you see where the whole industry is heading. So go ahead and create that account right now by clicking the link in the description. With the accounts created, as soon as a dedicated lesson on installing it comes in, we can just wire its own service at the right moment. So having them ready means that we never stop the build to go sign up for something. Once again, all the links are in the description. And with that done, let's dive right into building. Let's start from the bare beginnings by setting up a new empty project. Now, I created a new folder on my desktop, drag and dropped it into my editor, and you can just open up an integrated terminal right here. The goal is to set up a base Next.js application, and you can do that by running the command npx create next app add latest, and use / if you're already in the repository you want to create the project within. So simply press enter. It'll ask you whether you want to install it using the recommended defaults, using TypeScript, ESLint, React compiler. Yep, we definitely want to do that. And it'll now proceed with installing it. So give it about a minute. And as soon as it is done, you should be able to see a couple of files and folders right here. But let's go ahead and run the project first by running npm run dev, which will spin it up on localhost 3000. Now, in the latest versions of VS Code, you can also just click it and it'll open it up within an integrated browser. So in this video, you'll see me use this as well as the browser. Either way works. Here we also get some additional functionalities like targeting specific elements and then opening them up within the agentic chat so you can directly change them. But yeah, this is the app, the default Next.js screen. So now let me explain the generated project briefly. Most important stuff is contained around the app folder. So right here, you'll see a page.tsx, which is that default page. So for now, we can remove this default content, replace it with an refce, which is going to say home. This simply is a basic React arrow function component. And then if you go back to the home page, you should be able to see just a plain text that says home. Alongside the page, there's also the layout, which loads specific fonts and CSS, and then just simply renders whatever we're passing into it. There's also the globals.css, which includes the Tailwind CSS configuration, as well as some general theming and styles. There's the public folder for all of the assets and images, a package.json for scripts and dependencies, and there's also a tsconfig for setting up different TypeScript options. But yeah, the best way to learn about a new codebase is using AI. Whether it's a new project that you want to understand the structure of, or even more importantly, if it's an older project that you just got onboarded to. So I think this would be a nice point to set up our AI agent and that I tell you a bit more about the workflow that we'll be using for the rest of this project. See, VS Code has a very nice built-in chat feature that you can open if you press Command-Shift-P and then search for chat, or you should also be able to see it right at the top right. Here, this is the default built-in chat, but you can also install different extensions. For example, I have Claude Code installed right here, so I can very quickly initiate new chat conversations with Claude. If you head over to the Extensions tab and then search for something like Codex, you'll also be able to see a Codex or maybe like a Gemini extension if that's what you prefer to use. Either way is fine with me. The process that I'm about to show you works with all of the different agents. It's more about the tools that you put around the agent that make it work. So whatever you find works best for you, whatever you're paying for already, or whatever is within your budget, you can totally go for that. In this video, I'll be using Claude Code, and we're going to use it with a default model of Opus set to the effort of medium. And you'll mostly see me use it in a full screen mode. So let's test it out with a super simple prompt by telling it to explain the generated Next.js project structure and keep it beginner friendly, but technical. This should be pretty simple, and here we can see a bit about how the agents actually work. So it's actually using different tools like bash commands and reading specific files. It's thinking and then giving us a walkthrough of how everything works. So we get the big picture, the full information of all the files. The app folder is where the app router is, so this is most important. Here we'll be using Next.js's file-based routing, loading different fonts, and then displaying the homepage, the globals for the Tailwind, favicon, and here are some config files. And of course, we don't touch the node modules or the next folders. The typical mental model is that a request comes in for a URL, it next matches it to a page in the app folder, the page renders inside a layout, and then server components render in the server, send HTML, and then Tailwind classes are handling the styling. Pretty simple stuff for now, but every good project needs a Claude.md file. Not just an empty one, but if you want your agents to behave better within your project, then you have to have a proper agents and Claude.md files. That way, you're just providing more information about the code base and what you're doing to the agent so it can do better work. So let's focus on that in the next lesson. In this lesson, we'll create the most important file in the project, and it's the agents.md file. Currently, it has just some basic Next.js agent rules, but the one that we'll add is going to be significantly longer. So instead of typing it, I'll provide you with the full file. You can find it in the video kit link down in the description. And if you scroll a bit down, it is right here. So you can simply copy the agents.md file and then paste it right here over this one. I'm using an extension that allows me to preview the Markdown files in a bit of a prettier format, but any Markdown previewer will do. This file tells the agent what our application is, how it should be built, which tools are allowed, how features are planned, and when the AI is allowed to write code. It becomes the project's operating system that the AI must read before every implementation. So instead of repeating the same rule in every prompt, we write them once inside of the agents.md file. So let me explain what's really happening here. And this might sound simple, but it has a huge impact on the output quality. Most people treat AI like generic chatbot and then wonder why the output is inconsistent. But large language models respond heavily to context. So if you tell the AI it is a generic assistant, it'll optimize for being helpful. But if you tell it that it is a principal-level, full-stack engineer responsible for implementation quality, architecture decisions, testing, and security, it'll approach the task differently. This role establishes expectations before any features begin. We want the AI to think about the architecture, maintainability, testing, security, not about just generating the code it compiles. We also define the exact job we expect right at the top, and it is to understand the request, use the right project skills, create a clear implementation prompt, ask for approval, and then implement. Notice the order. The plan comes before the code, and our approval comes before either. And then before the product section, there's also a reference to Next.js docs. This is how Next.js has started handling knowledge for agents. No separate skill for it right now. If you scroll to the product section, you'll see that here we're describing what the product is actually about. Imagine hiring a new engineer. The first thing they'd ask is, what are we building? And that's exactly what we're answering here. In our case, we're building Skew. Skew is an application that collects real news articles from configured sources, analyzes them with AI, stores them in Supabase, and then displays reader-friendly sentiment and framing insights. But an even cleaner way of saying what the app is to tell it what to build. It needs to build a homepage where users browse articles as news cards, a news details page where users read the full article analysis, Clerk for authentication, Supabase for persistence, Oxylabs for scraping and scheduling, AI article analysis, logs, PG vector similarity search, Vercel cron for automatic scheduling, and minimal responsive UI. Do not overbuild. The more clearly you define the project, the less likely the AI is to make assumptions. So this line, do not overbuild, might be one of the most important lines in the file. As you know, the agents love adding features that sound useful. Maybe it'll suggest to add comments, bookmarks, notifications, recommendation engines, but none of that is needed as it's not part of the MVP. You must draw the boundary. Tell it what it needs to go into the project and what it must skip. Now, if we go to the workflow section, this is the main idea of how the AI should approach building features. You mention it to read the agents.md, to read the relevant skills, inspect the code, ask a focused question if something is unclear. This way, the AI doesn't jump straight into coding. It first writes the implementation prompt for our feature, saves it, and asks us if it's good to execute. We approve the prompt before it touches the codebase, and check out the last two steps. After implementing, it runs the available checks and then shares the exact steps to test or verify the feature. After that, in the skills section, we tell it which skills to use for the libraries we decided to include in the project. Thankfully, all of these modern tools support working with agents, so they've already created their agent skills. And finally, in the prompt sections, we're going to let the AI write the prompt and tell it to save each one into the prompts directory. Each one of the prompt needs to include a goal, a skills to be read, existing codebase inspected, decisions or assumptions, files likely to change, and all the other stuff which I believe is important for it to execute the task properly. For the UI, it'll also include things such as visual interpretation, layout, typography, and more. And feel free to take this AGENTS.md file because you can use it for any of the upcoming projects you create. In the architecture session, we keep the layers separate. On the website, we have the pages, cards, details, and so on. In the API, only the route handlers. Database includes Supabase reads and writes. For scraping, we use Oxylabs calls and scheduler integration. UI must display stored data only, not invented, and UI must not scrape, analyze, or mutate pipeline state. Then I tell it a bit about the tech stack that we're going to use Supabase as the source of truth with specific tables that we're going to have, and then how scraping is going to work. Then we tell it a bit about the correct scraping model, how the workflow should look like, and a bit more info on how and what to scrape and how to display it on our website. There's even a list of likely environment variables that we're going to have. But we don't need to read through all of this together because this is specific for this project, and we will get back to it later on as we develop some of these features. You can add other info, but the goal is to keep it simple so the AI knows what to do and what not to do. So in the next lesson, we'll set up the tool-specific skills for Next.js, Clerk, Supabase, and Oxylabs so the AI knows exactly how to use each service correctly. Let's do that next. In this lesson, we'll install official skills for all of the tools that we'll use to build our application. We'll install them from the tool team's own documentation, so the AI agent gets up-to-date tool-specific guidance. Basically, the agents.md file that we saw explains the tools. So we'll use the skills from Clerk, Supabase, Oxylabs, and AI SDK, and this will help us keep our setup clean. So make sure that you're in the right repo, right here at the root of your project. And let's first install Clerk skills. The installation is super simple. You simply have to say npx skills add Clerk skills. Run it. And if you haven't installed the skills npm package, which allows you to install all of those skills, you can install it now. And you can select Clerk, as well as I think we'll need Clerk billing features here if you want to add billing to the project. And you can also select Clerk Next.js patterns. Press enter. Here you can see that by default, these skills will work for these agents. But if you want to add it for some additional ones like Claude Code, you can scroll the list, select it, and press enter. Then you can choose whether you want to install it for this project or globally. For now, let's just proceed with this project through Symlink. And that's it. Proceed with installation, and the first set of skills has been installed. Next, let's install Supabase's agent skills. The installation command is once again super simple. You just run npx skills add Supabase agent skills and select what you want to get. In this case, we're going to go both with Postgres best practices as well as Supabase, and press enter a few more times to get it installed. Now, the core of our application are, of course, the news, which we have to scrape. And to improve the integration of Oxylabs, which we'll use for scraping, we can install their agent skills. On top of the skills, they also have specific plugins for Claude Code, but in this case, I'll proceed just with installing the skills by running npx skills add github.com Oxylabs agent skills. You can select Oxylabs, and in this case, we just need the web scraper. Press enter a few more times, and the skills are installed. By the way, check out the Oxylabs Agent Skills official repo. Head over there, take a look, and drop the star to support the project. And finally, as we'll use AI to figure out the bias of specific articles, we'll be doing that through Vercel's AI SDK. And thankfully, they have the skills for that too. So you can just run npx skills add Vercel AI. You can select AI SDK and press enter a few more times. Now, as I said, in this video, I'm teaching you the approach where the agent will generate the prompts for us. That's the workflow that we told our agent to use in this video. But over the last year, I've been also working on my own set of skills. The skills for agentic engineering workflows that guide you from the idea to scoping a feature, architecting it, and then developing it. The video you're watching today is super useful because it was the first step to get me to develop these skills. I've developed a set of skills that do that for you. These skills spend more tokens and take more time to develop, but the output that you're getting with them is significantly higher. So what I would recommend for now is maybe checking it out a bit, giving it a star because it really helps, and then continuing to follow this video as it is, as that's going to give you the under the hood look at how the skills came to be. And then after that is done, you can join the waitlist. And then after you watch the video, you can download the skills and try developing something of your own by following the workflow. You can also join the waitlist for the course in case you want to see me develop using this skill set. But with that in mind, after we install all of these skills, let's inspect the generated skill files in our .agents folder. Here, you should be able to see the agents for AI SDK, Clerk, Oxylabs, and Supabase. Everything is here. The extra Clerk skills like billing, orgs, and so on are fine to keep. They just support the main Clerk one, and you can use them for future feature integrations. So now that the AI has project context from the AGENTS.md file and the tool context from the installed skills, the next step is to put together a workflow. I'll show you how a simple prompt that we're going to write turns into an AI-written implementation prompt, how you can then approve that prompt, and how coding only starts after the approval. Now that the AI knows the project rules and tool-specific skills, we can finally build the first real feature. But instead of just jumping into the homepage, we'll start with the design system. This is important because our app has multiple screens. The homepage, the news details page, the auth screen, article cards, analysis section, badges, button states, and more. So if we let AI style each screen separately, the app will quickly become inconsistent. So first, we give it a UI reference and then ask it to create the visual foundation. Open up your new chat. I'll just go ahead and open up a new Claude window and tell it to implement the app design system from this attached UI reference. And this reference is something that I'll provide to you in the video kit link down in the description. So you can just attach it, and it's going to look something like this. Skew News, balanced news coverage powered by AI. Here we can see some primary colors, spacing system, grid system, the font we wanted to use, the buttons, and the card example. It's all here, and that's it. You can simply run it. And a pro tip, you don't even have to strictly tell it to read the AGENTS.md file at the start of every prompt. Modern AI coding tools will load the project agent rules automatically. You just have to make sure that if you're within Claude, it refers to the AGENTS.md file that is right here. So, as you can see, it automatically said that it'll follow the project's workflow, inspect the code, read the relevant guides, and then create a prompt file for approval before implementing it. It figured out that it's using Tailwind and that the reference is a full design system spec. And then it might ask you some questions. How much of the design system should this task deliver? We can say the tokens, components, and a showcase. This is actually recommended so that we can immediately visualize everything that it did. So let's go ahead and submit the answers. I actually used a GPT image 2.0 model. So if you're interested how to create these design images, let me know down in the comments and I can teach you in one of the upcoming videos. But yeah, the AI didn't start writing code. It read the agents, it read the named skill, it inspected the projects, and only now it'll create the implementation prompt. And there it is. You can find it right here under prompts design system. Since it's a markdown, we can preview it, and it looks something like this. The goal is to translate the attached Skew design system reference into the codebase as a real reusable foundation. It includes design tokens, the pop-ins type scale, and a small set of UI primitives, plus a design system showcase page that mirrors the reference so the tokens can be visually validated. It's saying which skills to read, the parts of the codebase to inspect, and finally files that it will change. So this looks good to me. Let's tell it to run it. If you go back to the agent, it'll say, I prepared the implementation. Is this good to execute? And now you can tell it, yes, it is. So let's give it a minute to implement it, and then we'll check out its work on the /design system showcase. And in about a minute, it came back with what it built. The full token layer is now within the app.globals.css. The color text primaries, background colors, left and right bias colors, radiuses, shadows, all of it is right here. It also implemented the fonts and creative primitive components for buttons, chips, bias meters, badges, and article cards. And what I love about it is that it also created a showcase page where it actually rendered all of those components. So the only thing that we need to do to test it is run npm run dev if we haven't already to spin it up on localhost 3000, and then open up localhost 3000 design system, which should look something like this. Skew news, balanced news coverage, brand colors are right here. And note, this isn't just an image. These are actual components that we can use. Different headings, body elements, UI elements, and buttons with hoverable states, chip categories, bias meters, an example of a card. All of it is right here. That way, the whole code base and its UI will be able to stay cohesive across all of these new features that we'll add. Now, in this situation, we approved the build directly from the existing chat. And when you do it in the same conversation, the prompt content is already loaded in the agent's context, the fact that it wrote it a couple of moments ago. So it implements it from memory of what it wrote, not a fresh read of the file. But there are two scenarios where the file and context can diverge. If you start a new session instead of continuing in the old one by simply creating a new Claude window like this. That way, the agent won't have the full prompt in the context. So without the explicit read, and now we can call it design system.md coming from prompts, and implement it, it won't know what it needs to build. So to make this more reliable, we'll modify the agents.md file. Head over into the agents.md, head over into the second step, which is the workflow. Right after 7, modify the number 8 by adding on approval, reread the approved prompt file in prompts folder and implement it strictly. Implement only after user approval. That way, it'll always go back to the specific prompt and follow it strictly. Now, in the next lesson, we'll use the same workflow to build a homepage using the design system that our agent just created. So let's do that next. In this lesson, we'll implement the homepage UI. So open up a new chat window and feed the new homepage design into it. It'll also be in the video kit link down in the description, but I would recommend downloading all the design images immediately as a zip and then unzipping them somewhere right here so that you can very easily drag and drop, for example, the homepage or one of the upcoming features. In this case, we'll tell it to implement the Skew homepage from this attached app. And Skew is just the name of our app. You can skew left, you can skew right, and this app is all about the news bias. So this is the only thing we need to do. Tell it to implement the page from the UI. Sounds super simple, a bit too simple, but then it'll read the AGENTS.md file and understand that its goal is not to implement it right away, but rather understand the code base and then create an implementation prompt that's going to be significantly more detailed. And it's possible that it'll ask you some additional questions in case it isn't 100% certain about something. What I love immediately is that it figured out that there's an established design system. So it's going to read the existing UI components to understand the patterns to build upon. No questions this time. It has enough data to write the implementation prompt. And the prompt is in. Let's quickly check it out. The goal is to build the Skew homepage at app page tsx to match the attached reference. A utility top bar, a sticky site header with logo, primary nav, auth buttons, and a horizontally scrollable category chip row, a top news section, and a responsive 3-column grid of vertical cards. Display only, no scraping, no analysis, no pipeline mutation, no live Supabase reads yet, because the data layer is not built. We simply only want to render from typed mock data so the layout can be validated pixel close and then swap to real Supabase queries without touching the presentational components later on. Perfect. This is looking good to me. So let's go back to the chat and tell it to implement it. And in about a minute, the build is in. The homepage is implemented. It replaced the placeholder app with full Skew homepage composed from new presentational components: the top bar, sidebar, category bar, and site footer. And all of these components are developed up to a very high coding standards. They do contain fake data for now, but all of that will be updated very soon. So the only thing remaining for us to do is to actually test it. Head over to localhost 3000 and verify it all looks good. And damn, it does. Already, I can see that it loads some fake images. A couple of images are broken, but that's okay because this is just the fake data. But it really does feel like a real news application. We have different categories at the top, the ability to subscribe and log in, some chips that we can click to filter by specific tags, and then here are the top news with our app specialties, which is the bias. So this is looking great to me. And we can also check it on mobile. So I'll open up an iPhone 14 Pro Max view. And by testing it like this, I was actually able to notice a small issue. And that is that the top bar is jumping out. So you can see right here that the top bar jumps out of the view. So we can simply tell it that. And you can use the voice for these corrective prompts. Sometimes it's a bit easier. On mobile devices, the top bar jumps outside of the primary content. Fix it. And now I'll let it do its thing. I'll stay on localhost in mobile mode so we can very easily see what is happening here. And when it implements the change, it should be able to just automatically refresh and we'll see it in action. There we go. Exactly as I was saying. That's perfect. So we can scroll normally right now on mobile and we can get back to something like desktop and it still looks great. Wonderful. And with that, we have not only implemented, but also tested our homepage on desktop and mobile devices. In the next lesson, we'll carry this forward and implement the News Details page UI in the same way. In this lesson, we'll build the News Details page. So simply open up a new Claude window and attach the details image that you were able to download from the media kit. It looks something like this. It still has the top bar and the nav bar, but then it has the actual article right in the middle. Here, our users can inspect the full AI analysis for a specific story. So we can simply tell it to implement the News Details page from the attached UI. Give it a second to analyze everything it needs, and then in case it has any questions, it'll ask us right here using the Ask Question functionality. And it looks like it's diving right in. It has a complete picture of the codebase patterns. Per the agent's workflow, it'll create a detailed implementation plan before writing any code. This is still a display-only UI task, so no feature skill applies. It's only going to build on the established design system tokens and primitives. So let's let it do its thing and write the implementation prompt. And very quickly, it came back with a detailed implementation prompt. Here's a summary of what it proposes, or you can just check out the full proposal right here under the News Details page UI. The goal right here is to build the Skew News Details page to match the attached reference. Top shared bar, site header, a 2-column layout, a related stories grid, a newsletter CTA, and the shared footer. Display only, no data for now. Later on, we'll get the data from the database. So I'll tell it that this looks good to me, implement it, and it'll just get to work. So let's let it work. And 2 minutes later, the News Details page is now implemented and verified. Here's what was built, following the approved prompt at prompts News Details page. It added a new page using the latest Next.js 16 params and 404 for unknown IDs. It created different article components and used different pieces of UI. It also created the layout data, and then it ran the checks to verify that everything is actually working. So news 1 gave a 200, whereas news 999 gave a 404. And then, as per the instructions, is giving us the manual steps to test it out. So we can head over to localhost 3000 and then navigate to the first card. If we click it, we should be able to see everything. So I'll open up the terminal, reload the application and rerun it, and then head over to localhost 3000. Here we can see the homepage, and then if you click on the first article, it's going to lead you to this new news details page that it created. Of course, all of this is just fake data right now, so the bias being calculated here is not correct, but you can see all of the UI components. It gives you information about what is happening, the related stories at the bottom, and even a newsletter that you can sign up to. And then it's giving you different sources that are covering the story. Looks very realistic, like a real news application. And who's saying it's not? If you decide to upload it to the internet later on, you totally can do that. You can make further adjustments and really make it your own. Later on, I'll teach you how to do a real AI analysis based on the scraped news data, not just the temporary placeholders that you can see now. Specifically, you'll also learn how the page gets related articles powered by PG Vector. And it's going to be different from a normal search, because a direct search matches words. So if you search election, it looks for the literal string election, so only 2 stories about the same event come up. But PG Vector works on meaning instead. So when the AI analyzes an article, we'll also turn it into an embedding, a long list of numbers that captures what the article is actually about. Then it compares it against all the others and serves you the best fit. So all of this is looking good to me now. We can also check it out on mobile view, and it feels absolutely amazing and mobile native. So I'll call it a day with this feature. So far, we've been focusing only on the UI. But immediately in the next lesson, we'll start adding some logic. Right now, our app still has 2 pages, the home page and the news details page. But the app still doesn't know who the user is. So in this lesson, we'll add authentication with Clerk. And I love it how npm install got replaced with add Clerk auth to my app, either through the agent directly or through CLI or the skills. Love it. That's the future of modern DevTools. And Clerk is more than just a login box. It's a full user management platform. So instead of using something like Supabase auth, which is a fair choice, we'll use Clerk because it provides us all of these components out of the box. It provides session handling and a stack of different OAuth providers with almost no UI code needed from us. And it also scales to organizations and billing later on in case you want to monetize your app. So the call for this app is to make Clerk own the identity and Supabase can own the data. That separation will keep both layers clean. So hopefully you already created an account at the end of the crash course. And if you haven't already, you can also create a new project. I'll call it Skew News. And here you can choose from all of the different OAuth providers. Email, phone number, username, Google, GitHub, whatever you want. In this case, I'll proceed just with email and Google. You can totally just copy the prompt right here from Clerk's onboarding process. But since we've already added the custom Clerk skill for Clerk auth, we don't have to do it. It's going to be even simpler. Let me show you. In the Clerk dashboard, under Configure, you can head over to your API keys, where you can find the publishable key and the secret key. Simply copy them, head back over into your application, and create a new .env.local file, and simply paste them in. Then open up a new agent window. Even though this one didn't spend too much of context, you can see it's only 10%, but it's always better to create a new window for each new separate feature that you're developing. And you can simply tell it to implement the Clerk authentication using the Clerk agent skills that we installed before. And press enter. So let's give it some time to create the prompt, and then we'll check it out. And it might ask you some questions, like should any routes require login, or is auth optional with a public news site with a login option? You can choose what you prefer, But in this case, I'll go against the recommended approach, which isn't something that I often do. And I'll tell it to protect the news details page, which means that anyone can browse the home feed, but opening a full article analysis requires the sign-in. But again, you can choose what you prefer. It'll now write the implementation prompt, and then we can execute on it. And the implementation prompt is in. The key decisions that it baked in. So let's check it out. The goal is to add Clerk Auth to our application, including the sign-in and sign-up flows, session-aware header UI, and route protection so that the news details page require a signed-in user while the home feed stays public. The goal is to wire up all the environment variables and keep the service server's boundaries intact. Key decisions that were baked in is that we're going to use the Clerk Next.js SDK with route protection, dedicated pages, and then a header placeholder where login and subscribe buttons become the sign-in and user buttons. So this looked good to me, so I'll tell it to implement it. And the auth is in. The build registers the proxy middleware and both app routes. Oh, and I love this. It says, note on the SDK, Clerk v7 current SDK remove the signed in and signed out components so it automatically use replacements. Show when either signed in or signed out API. So that's how skills always have the up-to-date info, and it just proved it right here. Okay, so to test it out, we can head over to localhost 3000. While signed out, try to access any kind of a details page, then sign back in, and try once again. Open up your terminal, rerun the application on localhost 3000, and this time I'll spin it up in a real browser. I'll try to open up the first article, and it'll lead me to a Clerk sign-in page. So I'll try to log in, continue with Google, and as soon as I sign in, I'll be redirected back to the homepage, and now I can access the article. And I can even see some information about my profile. You can manage the account or even check out the security. Believe it or not, that's it. We've successfully implemented the auth into our application. And if you want to have a better understanding of exactly what was done, you can ask the AI to explain each generated or modified file for this feature in detail, including the middleware, the sign-in and sign-up routes, and how protected routes work, as well as how the login button and user buttons are wired in the UI. AI is amazing for explaining specific parts of the code. So you can see here how the proxy works. It's going to give you the code, and then it'll provide you the explanation. Next.js actually renamed middleware to proxy, and it explains line by line exactly how Clerk Authentication was implemented. And if you've been paying attention, you saw that it implemented all of this without any mistakes or bugs. That's because of the workflow that we implemented. The workflow and the skills tell it how to implement it properly so that we don't have to have a lot of back and forth with the agents. So if you were already typing in the comments saying, this AGENTS.md file is going to spend a lot of tokens, well, that's not really the case. If you take a look at the context usage, it took only 8% to implement the entire authentication feature. But imagine if it wasn't that detailed. You would have to have a lot of back and forth with the agent to try to fix it. So take a second, try to understand really how this works, verify the login behavior, and in the next lesson, we'll dive right into implementing the Supabase database. Until now, the application has UI and auth, but the product data is still just temporary fake data. So now we need a database. And for this project, and many other projects that I'm building, we'll use Supabase as the source of truth. That means that the sources, articles, analyses, scraping logs, schedules, and scheduled run history all live in Supabase. If you head over into our AGENTS.md file, specifically if you head over to section number 5, architecture, you'll see that the UI must display stored data only. UI must not scrape, analyze, or mutate the pipeline state. It only displays what is already there in the database. So scraping and analysis are separate layers we build later. This is where we use Supabase. So if you haven't already, click the Supabase link down in the description, create your account, and then create a new project. Call it JSM_Skew news, and choose the region that is closest to you, and generate a new strong password, which you need to save because you'll need this database password later on. So save it somewhere safe and create a new project. It is completely free. Next, give Supabase a couple of minutes to provision your database and the rest of the stuff that you'll have access to directly by creating this project. Once it's ready, you can just pull up your project URL. You can find it right here under copy. So go ahead and copy the project URL, head back over into your VS Code, and head over into your .env.local. You can then paste it right here under next public Supabase URL. We'll also need a next public Supabase anon key. This is going to be the publishable anonymous key, as well as a Supabase service role key. So let's go ahead and copy them one by one. Publishable key is right here. That is the anon key that I've been talking about. And then finally, the secret key, which isn't here, but rather under settings, API keys, and right here at the bottom, secret keys. So you can copy it and paste it right here. With that in mind, you have everything you need to just get the database developed. I'll simply open up a new Claude window and simply tell it to implement the Supabase database and data access for Skew News by using the Supabase skills. Again, it seems a bit wrong just telling it, go ahead and do this, without having any expectations or telling it what it needs to do or what it needs to avoid. But again, we're not really executing yet. We're only telling it to start analyzing the existing code patterns in the current data layer and the AGENTS.md, and then to come up with a final prompt that's going to be super detailed so it gets it implemented properly from the first try. So let's give it some time and potentially answer some questions if it asks us mid-session. This time, we do get a couple of questions. The first one is, how far should this task go, data layer only, or should we also rewire the pages to read from Supabase? Yep, that's what I'll tell it to do. We want to form the database and then additionally point the home feed and detail pages at the new query functions. And it's asking us whether we want to see the sources table with the AGENTS.md example sources, like these famous newspapers, and I'll tell it, yes, go ahead and see them properly so we already have some active sources. And in a few minutes, the implementation prompt is in. Before we read the quick summary, let's actually give it a proper read. The goal here is to implement the Supabase's data layer as well as wire it to the UI. The schema, thankfully, was already provided by the AGENTS.md. It's going to include sources, articles, article analyses, logs, Oxylabs schedules, and Oxylabs scheduled runs, without the embedding column for now. It's going to see the database with some example sources. It's going to create handwritten database types, so we have type safety from the get-go. And then it'll create a Supabase client on the client side, as well as write queries so we can fetch those analyzed articles and sources. Finally, it'll wire it all together. All of this looks good to me. It is pointing one judgment call that it wants to flag. The mock models a story as a cluster of many sources, but the real schema is one article, one source. I map that honestly. Source count is set to 1 without redesigning the multi-source sidebar cards. This sounds good to me. Later on, if we need to fix it, we can always get back to it, but for now, this is looking good. So is this good enough to execute? Yeah, just go ahead and execute it. And you can see based on that addition that we added to AGENTS.md, it's actually going to reread the prompt and start implementing it, starting with package installs and then schema files. In this case, we're using Supabase.js, and it'll proceed creating these SQL files. And in a couple of minutes, all 3 checks pass. So not only has Supabase database been added and database access connected, but it also did a couple of checks. It confirms the build on the homepage and the news detail pages, which are now dynamic and server rendered, as well as the addition of the server-only service client enforced by the build. So it actually implemented the changes across a couple of different files, the SQL schema being a primary one. This is something that we'll have to manually apply in the Supabase dashboard. So we're creating tables for articles, sources, analyses, and more. Then in the seed, it's actually going to seed a couple of sources. There's the types that enforce everything is type safe. The server, which actually creates and exports a service client, and then the queries to actually fetch the articles and to display them. So to test them, we first have to head over into the Supabase dashboard under the SQL editor, and then copy and paste the schema and click run. We can do that easily by heading over here, heading over to SQL editor, pasting it, and clicking run. If it says something along the lines of success, no rows returned, we're good. The second step is to run the Supabase seed SQL function, confirm 5 active rows in sources. This again, you have to run right here, but make sure to override what you previously had. And this should run very quickly. So if you head over into the table editor, under sources, you should be able to see 5 sources added to your database right here. There we go. Then the next step is to ensure that we have the 3 environment variables, which we do, and then run it on localhost 3000. Back in the browser, I'll run localhost 3000. And now under homepage, we won't have any analyzed articles yet. So what we can do is insert an article manually into the SQL editor, or we can tell it to generate one for us. But first, it's asking us whether we want to save something to project memory. I'll say yes, save it, and give me the dummy article I can paste into the SQL editor. AI is amazing for just giving you quick pieces of data that you can copy or paste somewhere. And there we go. It gave us something that we can very easily copy. It's a self-contained dummy article we can paste into the SQL editor. So head over into here and just paste it in. And it's asking us whether we want to run it without RLS or with RLS enabled. I'll go ahead and enable it. And we got a success. So now if you go to localhost 3000, you'll see a single article right here. It's a real article coming from the database. You can open it up, see what it is all about, and that's it. You can also see our real source. But this is the article that we added manually. Even though it's real data in a real database, it's still dummy data. So in the next lesson, we'll build the Oxylabs Scraping pipeline. It's going to read the active sources that we just seeded, visit each homepage, and then pull real articles and insert them into the articles table automatically, the very table that this page is reading from right now. So let's do that in the next lesson. This page reads from the database, and we seeded the sources, but there are a few articles. I mean, there's one, and that one that is here is just a dummy article that we added manually through the SQL editor. So in this lesson, we'll build the engine that fills it, the Oxylabs Scraping pipeline that turns our seeded source homepages into real stored articles. But first, let me explain what this pipeline actually does, because it's more than just download a page. So head over into your AGENTS.md and specifically head over into section 9, correct scraping model. And I can check this out in preview. At a high level, the scraping will work like this. First, we load the selected active sources from Supabase. Then we obtain each source's homepage HTML, and manual scraping fetches the stored homepage URL live through Oxylabs. Scheduler processing uses completed Oxylabs job result, and the goal is to never crawl into sublinks to find more listing pages. Then we extract the candidate links from visible homepage story cards. We reject anything on the non-article reject list before detailed scraping. We then normalize and dedupe candidate URLs, and then skip URLs already stored in Supabase. That way we don't have duplicate articles. We then scrape only article detailed pages that pass the candidate URL check. We validate and clean each detailed page because it must pass the article contact gate. More on that later. We insert only the valid articles, append them, and that's it. But the thing that I want to point out here is that Oxylabs won't do a raw fetch. That's because news sites actively block scrapers. Oxylabs manages proxy networks and geocomplexity legally, so we can get a clean homepage HTML back instead of a page that's telling us that we've been blocked. It can collect real-time data from almost any public website, scale effortlessly without you having to manage those browsers, servers, and proxies, and integrates with tools that you already know, like Puppeteer, Playwright, or workflows like N8N. And it even has MCPs for Claude and Cursor. On top of that, it offers very low latency scraping, 24/7 support if you need it, and has been recognized as one of the best proxy services. Head over to oxylabs.io/JavaScript, where you can get a completely free trial, up to 2,000 results with no credit card needed, and if you upgrade, you can use the JavaScript code to get 20% off any plan. We'll be using the Web Scraper API. So let's get started with Google. As soon as you're in, you can see the testing that I've done, and when you're here, you can just get the API key by heading over into My Account in the left sidebar, and then right here under Web Scraper API, you can start a free trial. Since I was doing a lot of testing while building this application, I got upgraded, but you can see even with all the testing that I've been doing, I still spent only like $6. And that is me testing it through the entire process of developing the app. So you're gonna be more than good on the free plan, which you can start right here. When you create an account, you'll get your username and password. Make sure to copy those and not lose them. Then you can take them and head over into your env local and add the Oxy WSA username, and you can paste yours, and you can do the same thing with Oxy WSA password. And alongside that, if you head over into your AGENTS.md and search for Skew admin secret, you can see that this is being mentioned. You can add another environment variable that says Skew admin secret and make it equal to any kind of a strong secret that you choose. So this can be an automatically generated string of characters. Next, go ahead and open up a new Claude window and tell it to implement the Oxylabs Scraping pipeline using the Oxylabs Web Scraper skill as well as the Supabase skill to connect it all together, and press enter. This is a big multi-part feature, so the prompt file matters more than usual. Let's give it a second to review all the relevant code and then create an implementation prompt. It might ask us a couple of questions on the way. And after inspecting the existing data layer, the Oxylabs Supabase skills, and the Next.js route handler docs, it wrote the implementation prompt. The scope it planned is right here. The goal is to implement the Skew's news application's manual scraping pipeline, the post API scrape action route, and the layered scrape to insert engine behind it. On demand, it loads the selected active sources from Supabase. It fetches each source's HTML page through Oxylabs, extracts the visible story card links from the homepage, rejects any non-article URLs via the non-article reject list, normalizes dedupes, and everything else we discussed so far. As I said, this is a big feature, so the prompt file matters more than usual. While you're reviewing it, check that it reflects the pipeline rules from the agent. Thankfully, in this case, it does. So if the prompt looks good, you can go ahead and confirm it by putting out the shortest answer that you can give. And I think that's a single letter Y. I think this is going to be enough for you to figure out as, yes, go ahead and implement it. We're implementing one of the most difficult features with a single letter. And that's only possible due to the agentic workflow that we implemented before through the AGENTS.md file. And of course, thanks to the tools that we're using, such as Supabase and Oxylabs in this case, for scraping, because otherwise we'll just be getting denied while trying to scrape these types of websites. So now, since this is a big feature, let's give it some time to implement it. And there we go. This is the biggest response we've gotten so far, which makes sense for the biggest feature. It implemented the manual Oxylabs scraping pipeline per the approved prompt. All checks pass, linting, 0 warnings, and build also builds both the API scrape route and the API sources route, both of which were registered. So what was built? The scraping layer using this Oxylabs file, and the pipeline with scrape.ts, which uses the run manual scrape orchestrator. This includes the source selection, all active by default, live homepage fetch, extract, filter, dedupe, everything else we discussed so far. And there are 2 new API routes, both guarded with admin auth. How to test it? Set the keys, which we have already done. Here it called it Skew admin secret. If I'm not mistaken, we called it a bit differently. Skew admin secret. So you can do whatever the agent says right here. Make sure the name is correct. And then run npm run dev inspect the active sources by making a curl to API sources, and then make another post request to scrape the data, and then successfully scrape all three resources by passing your Skew admin secret. Okay, let's go ahead and do it. I'll rerun the application. And the first one we can actually do using the browser because it's just a GET request. And as you can see right here, when we go to localhost 3000 API sources, we immediately get back the 5 sources we have added so far. Now we can try to make an unauthenticated post request by copying this curl command, opening up another terminal, and then pasting it in. You'll see a 401 unauthorized. That's good. And then finally, we can try to scrape 3 resources by passing the admin secret. So do it like this. Go ahead and copy your admin secret, which is going to be this one right here, and just update it right here. Xskew admin secret. Here I can see that it does contain that X up front, so we'll test it out with and without it. At the same time, in our terminal, you can see that it scraped 3 selected resources. BBC MPR routers, fetching the homepage fetched 48 links. We got 118 links right here, and it's inserting them right here. From BBC, from 48 links, it got 0 candidates, but from MPR, it got 57 candidates, and it's starting to insert them. This process will take some time as we're trying to scrape a lot of articles. So let's let it run. And now it's taking a look at the final source, 53 candidates, 47 rejected, and it's trying to parse them. At the same time while this is happening, we can head back over to Supabase under the table editor and take a look at the articles that we have. And you can see that slowly but surely, we're building them in. There's the one that we implemented ourselves manually, which I believe is this one from the Unsplash photo. That's the fake one, which we want to delete now that we have all the real data. And as we're deleting it, new articles are going to keep coming in until the scrape finishes, which looks like it just did. So manual scrape completed, status completed, 3 sources checked, many candidates found, 25 detailed pages scraped, and here we got per source information. So if you head back, you can see that this completed. Wonderful. This means that we have gotten a couple of real articles, each with a real source ID, a URL, a canonical URL, a title, for example, talking about the largest housing affordability bill in decades. This is coming from NPR and more. So now if you head back to your browser and expect that if you head back over to localhost 3000, which is the homepage, that you're going to see the articles here, you'd be wrong. They're not going to be displayed here just yet. Thankfully, we know that they exist because we can see them in the Supabase's table editor, but on the homepage, we're filtering by the Analyzed At field. And you can see Analyzed At is currently set to null for all of these articles, which means that they're not yet accessible on the homepage. For them to appear there, they need to have the data about the AI analysis, which is what we're going to do in the next lesson. But for now, stop and appreciate what you've done in this lesson, as this one is the biggest payoff so far. From a single one-sentence prompt, you built a real production scraping pipeline featuring robust, uninterrupted data collection through Oxylabs, homepage parsing, a reject list for non-articles, URL deduping against the database, per article validation and text cleanup, and append-only inserts, all with full run logging with a summary. People spend days wiring this up by hand. But what you did now was our agentic skills workflow doing its thing. Here, we defined the tools and services that we're going to use. And then AI wrote the detailed prompt covering all of it and implemented it. You then reviewed that detailed prompt and said yes. It's that simple and easy. So now that we have real articles in the database, we need some insights on them. I mean, that's what our app is all about. We don't want to simply scrape and display. So in the next lesson, we'll build the AI analysis pipeline that reads from these scraped articles, generates a neutral summary, sentiment, and AI estimated framing, saves it, sets the Analyze At, and that is the moment that the homepage will finally fill with real analyzed news cards. So let's do that next. This lesson is where Skew News earns its name, because we'll figure out Toward which spectrum is the article leaning? We'll build the AI analysis pipeline that'll read each scraped article and produce its summary, sentiment, and AI estimated framing. If you head over into your Agents.md and head over to 19, you'll be able to see a bit more about the analysis. It must process valid articles, must be triggered via this URL, and here you can see what it'll save in the analysis. The neutral summary, the sentiment score, AI estimated political framing, left percentage, center percentage, right percentage, so where is it leaning, derived bias score, confidence, framing notes, loaded terms, disclaimer, and model name. Not sure where these extra characters are coming from. For you, they might not be there, but either way, that's okay. This right here is the heart of the product. The framing is AI estimated, not objective truth. And Skew News is going to present the user with an estimate with a disclaimer saying that the AI judged the article based on the article's own text and never from the source name. For the analysis, we're going to use the OpenAI API key. So go ahead and sign in to OpenAI API and then create a new project, which you can call something like JSM Skew News, and create a secret key, which you can then copy, head over into your .env.local and add it as OpenAI underscore API underscore key, and then you can paste what you copied. Then open up a new chat and simply tell it to implement the AI article analysis pipeline using the Supabase skills. I'm adding the Supabase skills here, but the AI will also read the AI SDK skills on its own. So press enter and let's see what it comes back with. And very quickly, it prepared the AI analysis implementation prompt. The goal here is to implement the AI article analysis pipeline described in Agents.md feature 19. Given articles already scraped and stored in Supabase, we want to detect articles that are pending analyses, run each through an AI model to produce a neutral summary, sentiment, and AI estimated political framing, and then validate the output with Zod. And finally, save it, append only to article analyses. Perfect. Sounds good to me. So let's go ahead and implement it. And there we go. The feature got built. This was the second biggest feature after scraping. So it did take a couple of minutes, but it is here and we got the full analyses. We already added the OpenAI key and we have the admin secret key as well from before. So now we can just run a single request to analyze all the current articles. Or you can do it like this, one by one. So let's go ahead and copy this curl request that you should have gotten as well. And it's so useful to have this way to test it. Again, this is also something that we manually added to the Agents.md file, so it let us know how we can actually test the feature. So to give it a shot, you can open up your terminal, run npm run dev, and then in the secondary terminal, you can paste this. But make sure to modify this admin secret key. Is it already pulling it from envs? Maybe it is. But either way, I'll just manually type it here and press enter. Now, if you head back, you'll see some information. Run started, 8 pending articles, batch 1 out of 2 is doing it 5 per batch, and it saved the analysis for this one, this one, this one, and it'll continue doing it for the next 4 articles. You can already head back to Supabase and reload it to see that now the analyzed ad actually has a timestamp, which means that now we'll have full analyses per article, which are being stored in this table right here. You can see the sentiment score is different. We get the summary of what this article is discussing, whether it's negative, neutral, the bias score, whether it's mixed, unclear, or something else, and is it leaning left, center, or right. As you can see, the confidence score for most is actually pretty high, besides this one where it's about 50%. Pretty cool stuff. So with that in mind, if you head back to localhost 3000 and reload the page, you're now going to see real articles loaded right here. And it's possible that for you, you're going to get an error. If you do, that's fine. You can debug it using the agent. But most likely, the issue is that it's trying to render specific images. So if you head over to next config, and if the images are being loaded from a source that you didn't allow, you can allow it for all sources by simply adding images, remote patterns, protocol HTTPS for all host names like this. Now, if you revisit the homepage, you'll be able to see a list of all articles that have been scraped with their AI analysis. Now, there are some what appear to be repeated articles. We're going to look into that later on. But the most important thing is that the articles that we have scraped, so we haven't entered them manually, are now appearing, and each one actually has the analysis. For example, Ryanair passenger partially sucked out of the window on a flight from Greece. And here you can see that this is mostly center, as it doesn't really have to do a lot with politics. But with something like this, talking about the white nationalist group Patriot Front, you can see that it's leaning significantly more toward left. And you get the full post as well as the AI summary right here discussing what's happening. We're not going to get into politics on this channel, but it is good to know that you can develop apps that serve any purposes as well. Some of you are going to do apps that have to do something with healthcare or serve anybody in general, but from time to time, it can also be news or politics. So yeah, it's all here. This is that satisfying moment, which displays everything we've been working towards so far. Not just the homepage with the real data, but also the news detail pages. Everything we designed and wired in the earlier lessons just came alive with real data end to end. So with this, our Skew News app is already a working product. It scrapes, analyzes, and displays real news with framing insights. And in the next lesson, I'll show you how you can go beyond just developing a code base and turning this into a real product. You'll do that by understanding how your users are actually using the app. Before we do some tracking on how users are actually using our app, I want to implement a feature that's going to make the app so much more usable instantly. And that is when you open up a specific article, you can scroll down and then get access to some related articles. Articles not related just by keywords, but actual meaning. And we'll implement that feature using pgvector with Supabase. As I explained before, the problem with normal search is that it matches words. So if you search for something like flood, in this case, it'll just match that same word. But two articles covering the same event with different wording would never get connected. And pgvector solves that problem by searching on meaning instead of words. It's a Postgres extension that Supabase offers, and it lets us store vectors right in the database and search by similarity. A vector, or an embedding, is just a long list of numbers that captures what a piece of text is actually about. Text with similar meaning ends up with numbers that sit close together. We generate those embeddings with OpenAI's text embedding small model, one per analyzed article, and then store it within the article analysis. To find the related articles, pgvector will then compare embeddings using the cosine distance operator and return the closest one in meaning. So related stops meaning shares a keyword and starts meaning closest in the meaning. And that's how we surface the same story from another source, even when the headlines share almost no similar words. Let me show you how to implement it. Supabase thankfully makes it super easy, so we can just open up a new Claude session and tell it to implement pgvector support and the related articles feature. Enable pgvector, add the embedding column, update the AI analysis pipeline to also generate and save embeddings, and then add the related articles section to the news detail page using the Supabase skills. Run it, and let's wait for a full detailed implementation prompt. And very quickly, it said that it inspected the schema, types, analysis pipeline, AI layer, queries, mappers, and the news details page, and read the Supabase skill plus the memory conventions. It prepared the implementation prompt for implementing the pgvector related articles. So let's go ahead and check it out. This is going to be under pgvector prompt. And the goal in this case is to upgrade the analysis pipeline to also generate and store OpenAI embeddings and add related articles section to the news details page powered by the pgvector cosine similarity. And I want to point out that this pgvector thing became so much more useful in the last couple of years when AI actually allows you to do proper matching. And that's what Supabase is all about. They allow you to very quickly spin up a new database and allow agents to just do their thing. Everything from database that you've seen in this video, as well as storage, real-time edge functions, but also things like AI and vectors, which is what we're looking into right now. So this is looking perfect to me, strictly following the feature 20 of the AGENTS.md. So let's go ahead and tell it to implement it and run it as it is. Let's give it some time to get it ready, and we'll review it soon. And in a few minutes, the implementation is complete with all checks passing. It built a Supabase schema, which enables vectors. So specifically, we're talking about embedding vectors to article analyses. So if you take a look at this part right here, you'll be able to see a new schema where we create this extension using PG Crypto, create a new table. And I remember the times where you had to write all of this SQL code manually, but those are no longer the times, and I'm very happy for that. Because development is not about just typing. Development is about thinking which problems you want to solve and what you want to achieve. And this is just the path to get there. So Supabase now is handling a ton of that stuff for you. There's also the types, the embeddings layer using AI, as well as the full pipeline and the new UI, which fetches the embedding server side and then passes it and then displays the final articles. And for this one, you will need an OpenAI API key. So you can just head over to Google, search for OpenAI API, create a new secret key, and add it to your environment variables. Before testing, head over to Supabase dashboard and run this SQL block right here that it provided you. So I'll head over to the dashboard, to one of my many active projects, and specifically head over to the SQL editor, override everything, and just run it. And this run failed, which I'm very happy about actually, because I got to show you this debug with assistant feature. You could either debug it right here, or you can take this message and then provide it to your agent, which has more information about your full code base and everything that's happening. So I'll provide it here. And it very quickly found the problem right here and gave us a function to rerun. So it updated the schema, which you can now copy, override it here, and just rerun it once again. This time it is running for longer, which is always a good sign because we get a success with no rows returned. So if you take a look at the second step right here, it is to first run this, then run the application on localhost 3000, and then trigger the analysis. The application already is running, but I'll just rerun it once again. Head over to localhost 3000, and then visit a specific article. And if you scroll down, you won't be able to see any articles yet. So the next step is to trigger the analysis. You can do that by copying this command and heading into a new terminal where you can paste it. But don't forget to get this Skew admin secret, which is in our envs right here, and then just simply replace it. If you do this, it'll seem stuck, but then if you head over to your original terminal, you'll see that it's actually running the analysis on the current articles that we have so far. And for each one, it'll say saved analysis plus embedding. And these embeddings is what's going to make the related articles work. This is super useful for suggestions or recommendations of specific data pieces. It can be news, it can be podcasts, it can be information cards, whatever it is. Embeddings are the fastest and the most efficient way to show you recommended content. So let's give it some time until it runs, and then we'll test it out. But even while it's going, already some articles are in. So I can see some top news appearing right here. And if you head over into it and scroll down, you'll be able to see the related stories section. And here you can also see the source that it is from. All of these are from Guardian, and you can see the narrative. In this case, it's all positive, but there is one negative one right here. So for example, we can click on this one and you can see it picks it up, or maybe we can go with this one right here. So now this makes users stick longer with your app and explore more articles because they can just come to the end and explore the first article that is most related to that story. Wonderful. I'll let it proceed with the analyses, but we're actually done. And you could verify it on Supabase, but thankfully we verified it already within the application itself. So that's it. Alongside the database storage, there's also these vectors, which are becoming so much more important nowadays to match and show recommended content. And I remember the times where it would take weeks to set up something like this. But nowadays, as Supabase says, build in a weekend and scale to millions. You built the design system, the pages, auth, the database, scraping, AI analysis. But writing and shipping code is not the same as shipping a product. A product is code plus knowledge on what's happening inside it once real people use it. For years, analytics meant you look at the dashboards and decide what to fix. But PostHog is pushing past that into what they call self-driving. The idea is that PostHog already has your product data, errors, session replays, funnels, support tickets. So instead of just charting it, agents can read it, cluster what's worth fixing into a report, and then open up a pull request with the fix already attached. You wake up to diffs to review, not the dashboards to interpret. And that's the same idea you've been running the entire time. You gave your agents the rules, and it wrote its own prompts. Self-driving gives an agent your product data, and it writes its own fixes. It's the same mechanism, pointed at a live product instead of a code base. Nothing ships on autopilot though. A human still needs to merge. You are the driver. And most of us will actually drive it through PostHog on Slack. You simply tag PostHog in a thread with some kind of a data question, like why did my signups drop last week, or some kind of a change that you want to add. And it answers from your own data or just opens up a draft PR for you without you having to leave Slack. So let me show you how all of it works and how you can implement it for this project and all of your upcoming projects. First, click the PostHog link down in the description and create your free account. If you're new, you'll most likely be redirected to the onboarding. And if you've developed some projects before, you can just manually head over to onboarding by changing the URL. It'll ask you what you want to use the PostHog for, like understand how users behave, find and fix issues, or collect feedback. Either way is fine, because the best way to install and set up PostHog is through their wizard. That way, you don't have to handle any envs or capture things on client and server. PostHog Wizard will do all of that for you. It'll basically wire itself into your codebase. So simply open up your terminal, stop it from running, and run mpxy PostHog Wizard latest. And if you have a specific region, you can add that too. Just run it. It might ask you to install the PostHog Wizard. So simply press Y and then install it. And here's how it works. It automatically figured out that we are in this directory, that we're using Next.js, and that we want to integrate PostHog. So simply press enter to continue. It'll ask you to authenticate directly within the browser and choose a project that you want to develop within. I'll create a new project called JSM Skew News, and you can do the same on your end as well. Simply authorize PostHog Wizard, and then that's it. You can return to your editor. The PostHog Wizard will now install the SDK, make it work on both client and server side, write the next public PostHog key into your env. It's public, so it's safe on the client, and create starter events and dashboards from your actual app. This means that it'll figure out what the app is all about and which events you might want to capture, and then it'll proceed to track the entire application for you. So, since we already have a lot of code in our code base, let's give it a couple of minutes to analyze it all and self-implement itself. Then, once it's back, we'll figure out exactly which events is it tracking. And there we go. It is done. On the previous screen, it showed me the full implementation and the link to the dashboard. I accidentally skipped it, so it led me directly through the MCP installation and PostHog in Slack. But you were able to see it on your end, and we have the dashboard right here. It has been created for us, so we can simply preview it. Check this out. This is pretty crazy. It pulled the analytics for the pipeline operations, the newsletter subscriber clicks, the articles views by bias label, so we know who is using it more or which articles are getting more clicked, as well as the article engagement wizard and article clicks over time. This data so far isn't real, but as soon as we start using the app, it'll start collecting real data and we'll be able to see it right here within the dashboard. So if you run the app on localhost 3000, reload it, and click over in a couple of articles, you'll be able to see some events are getting tracked. And back in the dashboard, if you head over under activity, you'll be able to see exactly what is happening. PostHog has been successfully wired up. But the next step that builds directly onto what we've done so far is to set up PostHog in Slack so that we can ask it questions about product data, debug issues, and just generate PRs without even leaving the thread. So you can just open up the Slack one-click setup, which looks something like this. So you just have to allow it for your workspace. And that's it. We're connected. You can go back to PostHog and keep using it through its dashboards, the general starter dashboard, which is how we have been looking at analytics so far. You can also look at it through the wizard-generated dashboard, already much more valuable info, or we can start asking it questions directly through our Slack application. So let's keep using the app a bit more so that we can fully test it out. But before we do that, I'm noticing at the bottom left corner that we have some issues. PostHog.js exception auto capture failed to load script, which I will copy and bring back to our Claude code. I'll say I just implemented PostHog, and this is the error that I see. And then we can just paste what we copied. And I'll do the same thing for the second error right here, talking about the surveys. And then I'll just paste both errors here and tell it to fix them. It'll now analyze the code base and PostHog's implementation, and let's see what it makes of it. And after some fixing, it says for the exception auto capture error, there's a real trade-off since it's the feature you may want to keep. So it's asking us the exception auto capture script is blocked by the add tracker blockers, like some kind of a uBlock or Brave Shield. Our server proxy is fine, so it's asking us how we want to handle it. And this is actually what I suspected will happen. When we deploy the application, the console error won't be there because we're going to be in a real browser, not running it locally. And if the users are running it without a blocker, they're going to get full error tracking. So, yep, I think we're totally fine on this. For now, we just disabled surveys, and the rest works properly. This console log will be gone on the deployed version. So now you can go through a couple of articles, explore the application a bit, maybe even log out and log back in. All of this data is now being tracked, and I'll show you how we can make sense of it. So just try to use the application a bit more. Then, if you head over to PostHog, you'll be able to see that all the data is properly getting picked up, like even the identify, where it identified our random account with this email and connected it. So now we have a bit more information about what this user is and what they do. So if you open up Slack, in this case, I just created a new channel called PostHog Testing, but you can invoke PostHog in any chat. You can simply ask it some kind of a question. For example, which articles got opened the most? And let's see if it can figure out what we're asking and deliver us a quality response. Since this is a private channel, we have to manually add PostHog within it, and it already responded, saying that we're connected to multiple projects. You can see that we're using this for the official jsmastery.pro domain, but now we can specify that the project we want to use it for is actually Skew News. So let's invoke it like this. There we go. And we will restart the question. Immediately, it flags it as in progress. And if you really want to eavesdrop, you can see what the agent is doing. So it's taking all of this context, figuring out what the query is all about, using the MCP to extract the data and give you an answer. Or, of course, you don't have to do that, and you can just stay within Slack and expect your answer back. And just like that, the response is in within literally a couple of seconds. Here are the most opened articles by article viewed events. So this one, which I clicked on a couple of times, is the most opened article. It has been opened 13 times, following by this one with 12 opens. All of this is early testing traffic. Now, let's ask it a bit of a tougher question. Something like, hey, PostHog, what's our drop off between the home feed and an article page? I really want to know, are we really activating the user to get them to check out specific articles? And keep in mind that I didn't write the query or a tracking plan. I simply described what I wanted, and it gave me the answer from my own product data. That is the self-driving that I was telling you about. And the response is in Right now, there's effectively no drop-off to report because the project has just one person across all events. 29 article views, 13 article clicks from a single user. This is a test dev traffic, but you can see how meaningful this answer is. And as I told you, PostHog doesn't only provide you the data that you have in a meaningful format, it can also draft a PR on its own. For example, you might want to track the amount of people that click the links at the bottom. If that's not being tracked already, you can tell it to track that for you. Or maybe you want to know whether people are really interested in how we analyze bias. So you can tell it to add tracking to this button. I think this is a good test. So let's see if it can do that. I'll tell it, hey, PostHog, in the app, we have a button that says how we analyze bias. I want to be able to track the amount of people that click on that button. If that's not being tracked already, can you make it happen? So this is a pretty open-ended question, and I want to see how it'll react in this situation. And very quickly, PostHog came back to me and said, already tracked, no code change needed. Your app has auto capture enabled, so clicks on that button are being recorded automatically. 16 clicks so far, though all came from a single test user. And to make it easy to watch going forward, I set up two things. Clicked how we analyze bias matches any auto-captured click on that button, as well as the insight on the unique clickers. So it didn't just tell me, hey, this is already being tracked, but it also created the insights so that whenever I want to, I can come back on my dashboard and check that number out. And you can see that this was created for us. That's what the self-driving is. You tell it the destination, it drives, asks for your feedback if it's needed, and then it just brings you to the destination. Works very similarly to our current agentic engineering setup with the AGENTS.md and the prompts, where AI is technically self-driving itself, but you're still the architect behind it. And I embrace this change. With the self-driving mode, PostHog is challenging the status quo, where you're just looking at data points within a dashboard. Why do you need a dashboard if you can simply ask the agent what you want, and preferably, you can ask it that question directly within the platform that you already use to communicate with the other teammates. Great stuff. So with this done, let's improve our application even further. Skew News now works end-to-end, but every part is manual. We trigger scraping and analysis by hand. So this lesson is the last piece of the build, because we'll automate the whole thing so that Skew News pulls and analyzes fresh news every hour on its own. So if you head over to AGENTS.md, and that's going to be under 18, right? Right here, we're going to talk about the Oxylabs Scheduler. We'll use this feature to run hourly scraping for active source homepages stored in Supabase. Scheduler should scrape source homepages only. And there's one distinction I want to make here. This is two separate one-time setups. We'll create Oxylabs schedules, but also configure Vercel cron jobs as two independent one-time setups, and neither one triggers the other. The post API Oxylabs schedules tells Oxylabs what to scrape hourly. It's done once per source. But then the Vercel cron config will tell Vercel to call API cron pipeline at 15 minutes past every hour. And both must be completed for the pipeline to be fully automatic. Until Vercel cron is configured, the process route must be called manually. So in simple words, the Oxylabs scheduler tells Oxylabs to scrape our active source homepages every hour and then store the results. And then Vercel cron tells Vercel to call our pipeline 15 minutes later, take these stored results, turn them into articles, and analyze them. That's also only set up once. So you're wondering, why have two and not just one, like scrape, store, and analyze in a single shot? There's a couple of reasons. First is that the Oxylabs scheduler doesn't call our app. It runs the scraping on Oxylabs' own servers and stores the results there. It's not a webhook that hands us a finished payload. So we have to always come back and fetch the completed results ourselves, which is what the Vercel cron does. That's also why it waits 15 minutes. The scraping isn't instant. And at the moment the job kicks off, there's nothing ready to process yet. So even if we could do it in one request, we wouldn't want to. Scraping every source, parsing detailed pages, and then running AI analysis on them in a single HTTP call would blow straight past serverless function time limits, and it will just time out. But splitting it Oxylabs handles the scraping on its side, and our cron processes the results and then analyzes them in batches. So to implement it, go ahead and open up a new agent window and tell it to implement the Oxylabs Scheduler with Vercel cron for automatic hourly processing, and use the Oxylabs web scraper as well as the Supabase skills to do it. This is the biggest feature in the project, and it's going to ship several parts together. So let's give it some time, and then let's review the prompt it generates carefully. It thought a bit and told me that it has a complete picture. So the Oxylabs schedules and Oxylabs schedule run tables, plus the types already exist. The scrape pipeline already exposes the process source HTML. The run analysis is a reusable step. Manual scraping uses the real-time endpoints, and the scheduler uses the data API, which means that a new client module is needed. It all makes sense. So based on it, it prepared a complete prompt to execute. We can review it here. The things that we care about the most is that it delivers all the pieces at once. The goal here is to implement the Oxylabs Scheduler and Vercel cron layer so that the active source homepages are scraped automatically every hour and then turned into analyzed articles with no manual intervention after one-time setup. What we care about the most is that it delivers all the pieces at once. All of this is looking good to me, so we can go ahead and confirm it. I'll simply go ahead and say implement. And very quickly, the response is in. It built the Oxylabs Data API client with create schedules, listing schedules, getting scheduled runs, using the /runs with per job result status, never just jobs. It sets the schedule state and gets the job result HTML. The schedule IDs are extracted from raw response via regex and kept as strings. DB layer-wise, it created the queries for the schedules so that now we can fetch them. As far as the pipelines go, it'll happen on an hourly basis, and then after that is processed, we will analyze them. So here's how we can test it out. First, let's create and sync Oxylabs schedules, one per active source plus deactivate orphans. We can do that by running the curl, and we have to pass our admin secret. So let's give it a shot. I'll open up my terminal. I'll do it in a new terminal window, and I'll manually provide the admin secret right here. Press enter, and it'll start doing its thing. You can see that it is either creating new schedules or deactivating the orphan schedules. To be able to see this, I switched over to my terminal where we're running the application, and you can see that the sync has been completed. Sources checked 5, schedules created 5, and that is it. We can see the schedules for all of the major newspapers. Then we can list the stored schedule rows. This should be simple. And you can see that we get back the data. And then after Oxylabs runs, top of the hour, process the completed results. So I will run it, even though Oxylabs didn't run yet, and press enter. And this is what we got back. After this, we can run the fourth command, which shows us the runs. And then finally, for automatic pipeline locally, we can run the pipeline. This will give you some more information on what's happening. But for all this to work, we also have to set up Vercel cron. So if you head over to a vercel.json file, you should be able to see a pipeline created automatically for us. The path points to a API cron pipeline, and it's going to run 15 minutes past every hour. So with the last command we ran, which was this one, we just tested it manually without waiting for it to get scheduled. To verify it, you can head over into your table editor and go under the Oxylabs schedules. It has to have one active schedule per source. As you can see, we have 5 sources, so 5 schedules make sense. And you can also check the Oxylabs schedule runs. Right now, this table is completely empty, but later on, once it runs, we should be able to see them right here. We ran these manually, so I expected that maybe something is going to be there already. So what I can do is copy all of the outputs that we got from running these commands, and then we can paste it over into our agent and tell it, these are the commands that I ran, paste them right here, and then specify that Oxylabs _schedule _runs is still empty. So we can say, but Oxylabs _schedule _runs table is still empty. And let's see what it says. And very quickly, it says that everything checks out. The empty runs table is correct, not a bug. Oxylabs itself confirms it. Here's the BBC schedule reports. The schedules were created at 11:05, and the cron is 0 hours, top of every hour, which means that nothing runs until 12 on my end, so there's genuinely nothing to process yet. The parser verified it against real data, so the 1200 hours pipeline will find the completed run, record it, fetch the homepage HTML, scrape it, and then mark the job as completed. So in this case, there's nothing left for me to do than just wait, which I guess is the whole point of the application. For me to not go ahead and manually browse the newspapers, try to figure out the bias and political agendas, but rather wait on the dashboard and potentially be notified when the results come back in. So while we're waiting for this, I actually want to go a step forward and deploy the application. We want to put it online, and there's a couple of reasons to deploy it. The first one is that deploying it will make the application public, so other users will actually be able to use it. And the second is that it's the only way for the automatic hourly pipeline to actually run, because Vercel cron will not fire on your laptop. Rather, it runs only on a deployed project. So at this point in time, our application is finished. We're scraping the articles and analyzing them for bias. So let's go ahead and deploy it. Push all of the changes you have so far onto GitHub. You can do that easily by heading over to github.com/new. Then you can choose your repo name, such as Skew News, and simply create a new repo. Then you can copy some of these commands. So first we run git init, git add dot, git commit -m, first commit. We can also branch over to the main branch from master, and then add a remote origin to this remote repo. Finally, we can push it over to origin main, which will bring all of our code right here to GitHub. Once the repo is right here, you can head over to vercel.com and add a new project. If you head over to your account, you should be able to see Skew News just now, so you can very easily import it. And we then have to set up the environment variables. And this is the step that most people get wrong. You want to head back here and copy all your local environment variables. Then simply paste them here. And there's an additional variable that you have to add for cron jobs to work. And it is called, let's add it right here, cron_secret. And this has to be a string of 16 or more characters. That's the recommended value. And make sure to copy it in case we need to use it later. For now, click deploy. And let's give it some time. It's first going to initialize the dependencies and then build a project. And that's it. We just deployed a new project to JS Mastery Pro repo. For you, it's going to be your own name. But yeah, here we are. You can open it up and you can see that PostHog warning is now gone. And we can see the app right here. The next and optional thing is to point Clerk at the deploy domain, because the test keys work only for local development. But for the live side, you'll need to configure your Clerk instance for production domain, and then add the Vercel URL to your Clerk application. For now, it is still using the local one. So I'll proceed to sign in, and we're in. So now we have to confirm that the cron job got registered. Head back over to Vercel, open up your project. You can use the find right here to search for the cron jobs under observability, and you can see whether it picked up on it. For me, it isn't here. So we can further debug it. I'll simply copy this page, at least the most relevant information, head back into my VS Code and open up my conversation with the agent. In this case, I'll open up the conversation that we've had before, because what we're doing is still relevant to this implementation. And I'll tell it, I deployed the project to Vercel, and this is what I see on the cron settings page. This should give it enough insight into what I'm trying to fix. I was assuming that because we have this Vercel JSON, it'll be able to automatically pick it up. In this case, no data found for the last 12 hours doesn't necessarily mean anything is broken. That panel shows cron executions, which only appear after the job has actually fired. But it's checking the other gotchas right here so we can verify everything. Specifically, talking about the Vercel plan limits, as different plans might allow you to run cron jobs at different time points. For example, it says right here that our pipeline is set to 15, which is likely a blocker because it depends on the Vercel plan. So the hobby plan hourly limit, which is most likely what you have, limits the cron jobs to once per day. So the cron expressions that would run more frequently will fail during deployment. Our schedule is set to hourly, and I can run that because I have a Vercel Pro plan. But for you, you might need to switch it over to every 12 hours. So it's asking us which Vercel plan is the project deployed on. Since I'm on Pro, I will select Pro. And again, to fix it for you, you can select Hobby. Considering that I'm on the Pro plan, everything on the code side is correct and shipped. We just have to wait a bit. Confirm registration, not observability. So go to Settings, Cron Jobs. If we go here, once again, you can search for cron jobs under Settings, not observability, and you can see that our API cron pipeline had been added here. Then verify its production deployment. That seems good to me. Set the cron secret, which we already have, and then run a quick manual test. Then wait for the next 15, which means that everything is working and that in about half an hour from now, I'll be able to get all the new articles scraped and analyzed right here on my landing page. So take a second to look at what you've built. Skew News scrapes real news from multiple sources, analyzes each story for sentiment and AI estimated framing, and shows it all in a clean, authenticated UI, and even refreshes itself every hour, deployed and running on its own. That's a real production-style product. But this is just the starting line. Everything we build is a foundation that you can keep building on. And the way you'd add to it is by using the same loop that we've used the whole time. You can further let signed-in users bookmark or save articles. The Clerk and Supabase combo should make that super simple. You can add search, topic filters, or trending session. You can implement connected related articles by using pgvector, or even send a daily or a weekly email digest on top of the analyzed stories. Or just niche it down and sell. With Clerk Billing, you can super simply add a pricing plan to your application. And let's be honest, that serious scraping that we're doing with Oxylabs really makes it a paid product. So don't just sit here and watch me do things. Actually go on and try to implement some of these. It's the same loop every time. Decide what the feature is and write the rule into the AGENTS.md. Once that is done, open up a new window and give a quick prompt explaining it. The loop doesn't care whether the feature is small or large. It scales with you. The AI didn't replace us here. It simply amplified what we can do. It took our decisions and turned them into working software fast. So the skill that matters isn't coding. It's knowing what to build and being able to direct it well. And the full agentic engineering course that takes the same approach and pushes it even further with skills that plan the reviews themselves, legacy code bases, recovering broken projects, and agents running in parallel, it's not out yet. But I'll leave the link down in the description that gets you on the waitlist and the best price once it goes out before the public launch. So it's worth grabbing now while it's open. So thank you for building this amazing application with me, and I'll see you in the course. Have a wonderful day.